Hi there, welcome to this session on System Design Deep Dive. So in this series of sessions, we are going beyond just tools and frameworks. We'll focus on how to approach a real-world data engineering problem like a system architect. So we take a use case of an IoT sensor sending data every seconds, and we need to detect anomalies in real time using a machine learning, right? But this may sound complex, but with the right system design mindset, we can break down into clear logical stages. So what we'll cover in this series of sessions is how to read a problem statement and break it down into stages. Next, we look at what questions to ask at each stage. And then we also look at what is the end goal of this stage. Then we look at what are the available system tools or design options what I have at this stage, and then we'll choose a system design option for each stage of the problem, and then we'll see like what are the considerations before I choose this particular option. So and by end of this series, you not only understand how to design a streaming ML pipeline, but more importantly how to think like a system designer. So with that, let's get started. So let's start with the problem statement first. So I'll read out in a loud first. So in a large industrial facility, hundreds of IoT sensors are installed on various machines to monitor metrics like temperature, vibration, and pressure. These sensors continuously stream data to central system, generating over 2 million events per day. So the goal is to detect abnormal behavior in any of the devices in real time using machine learning. The system must handle high data volumes, operate reliably with minimal delay, and store both raw and processed data for audit and further analysis. So at first glance, this may sound like just like a business use case, but if you put a system designer hat, this has got a lot of architectural clues which you need to work on. And we'll see that what are those architectural clues in this statement, and then how to break this into logical stages. Now let's break it down. I have highlighted the sentences in the problem statement which gives us some hint on what exactly these statement mean. So let's start with the first hint what we're having in this problem statement. Continuously stream data to a central system, right? So this tells us that we need a scalable data ingestion layer, something like Kafka or Kinesis, or maybe any other similar streaming platform we need at this stage. That is, mostly we are talking here about the data ingestion part. The next sentence what we see in our problem statement is detect abnormal behavior in any of the devices in real time using machine learning. So this defines our processing and inference layer. So we need something that can handle a real-time decisioning. At the same time, it has to read the data in real time at scale. Important word is scale. And then invoke and do an ML inference also in real time or near real time. So we might need something, we need both here. We need something like a stream processor which will process my streaming data which is coming to Kafka. It could be something like a Spark structure streaming or a Flink or a Glue streaming. We need to explore all options. And then we need an inference layer. That means once the data is read, processed, we need to invoke an ML model that would actually tells me whether is there an anomaly in this data, right? And next sentence that gives us a cue is we need to store both raw and the processed data for audit and further analysis. So this tells us a storage layer with both raw data and enriched output, maybe something like an S3. So we discuss whether we require something like a data lake, or we require some data warehouse, or we require some NoSQL database store. So we need to evaluate all the options over here. And most importantly, we need to consider about the schema, partitions, and retentions. And another subtle but critical line what we see in this problem statement is handle high data volumes and operate with a minimal delay. So what it means is that we are not just, this sentence is not just talking about the functionality. It is telling us that we need to optimize this entire system for a throughput, latency, reliability. So that means it has to be there across the pipeline. So from this single paragraph, we have derived three major stages of our design system. Number one, data ingestion layer. Number two is data processing and inference. Number three is storage. Now we'll go in details of each of these stages. What are all the considerations in each stage? What are the available design options available at each stage? Before that, let's first see what these stages are all about. So now that we have something like unpacked the problem statements, now let's lay out the how we are going to break this down into three important stages, or maybe you can call them as a pipeline or a stage, but I use the word stage here just for a discussion purpose. So stage one, ingest the data. This is where we connect to IoT sensors, capture their telemetry streams, and feed the data into a reliable, scalable system, something like Kafka or Kinesis. We'll explore more of them in the coming slides. Stage 2 is processing the data. Here we apply real-time processing logic, something like we have to parse the data, we have to clean the data, we have to filter the data, we have to aggregate the data, so that we can the data is ready for the inference. So the whole goal is detect anomalies. That means I should be able to invoke an ML model which can detect anomalies based on my streaming data. But to invoke an ML model, I cannot pass a raw data. I need to take the data, maybe clean it up, maybe enrich it, maybe aggregate it. So I don't want to invoke like every second. Maybe I might want to group them by every 1 minute or maybe every 5 minutes. So I need to aggregate the data from last 5 minutes for a particular sensor, right? So that is the whole idea of this stage. Next, in stage 3, we store the data in the, so we'll go what is storing data means that once the data is processed, we need data for future audit analysis, or maybe I want to build a real-time dashboard on how each sensors are performing, what is the health of each devices. So I might want to build a real-time dashboard also based on the incoming streaming data. So for that, I need to think of how do I store this data, right? So in the rest of the sessions, we will go stage by stage. So where for each stage, we will ask three important questions. What are the questions I need to ask in this stage? And what is my end goal of this stage? And then what are my design options for this stage? And then what design options I need to choose and why I'm choosing a particular design options. And more importantly, which is common across all the stages is security, monitoring, governance. These will be a common threads discussions points across every stage. So then at the end of each stage, we'll recommend what is going to be the design option for this stage. So that is what I'm going to explore in the coming sessions. So see you again in the next session, which is about the ingest the data stage, where we'll discuss about all the design options for that stage.